Artificial intelligence is, well, it's not science fiction anymore, is it? It's really woven into pretty much everything we do day to day.
Oh, absolutely. It's recommending movies, helping us write emails, pushing innovation everywhere.
But with all that power and integration, there's a flip side, a big one.
Definitely. The cybersecurity threat landscape is evolving like crazy, specifically targeting AI.
And it's fundamentally different terrain than what we're used to with, say, traditional software security.
That's spot on. AI systems learn, they process data, they generate outputs in unique ways, and that opens up completely new avenues for attackers.
Yeah, we're not just talking
Yeah.
about crashing systems anymore.
No, it's often much more subtle. Manipulation, bias injection, things like that.
And getting a handle on those unique threats is exactly why we're doing this deep dive today. We're going to unpack a really significant document.
Right. It's the ETSI Technical Specification 104223 V1.1.1. Came out in April 2025.
So pretty recent stuff. And if you listening are involved in, building, deploying, or even just using AI systems day to day, this doc is, well, it's foundational.
Think of it as a baseline, yeah. It sets out these essential cybersecurity requirements specifically for AI models and systems.
And it doesn't just rehash old security advice.
No, it draws on existing good practice, sure, but it crucially adds new measures, things specifically tailored for AI's quirks. It acknowledges that, traditional security playbooks just aren't enough here.
One thing I really like about it and how we're planning to walk through it today is the structure. It follows the whole AI lifecycle
Exactly. From secure design right at the start.
through development, deployment, maintenance.
And even end of life, which often gets missed.
Yeah. So we'll basically act as your guides, taking it section by section, highlighting the really important bits and explaining why they matter for you.
Our goal really is to distill the key takeaways from the standard.
Mm-hmm.
We want you to leave this with a solid grasp of these baseline security needs across that whole life cycle.
And understand why they're so vital for the future of secure AI. It's about equipping you with that core knowledge.
Exactly. Giving you the tools to be informed.
Okay, so let's dive in. Where do we start? The big picture, maybe. Who is ETSI? Why this document now? What are the key concepts?
Right. Let's unpack that. So the source is ETSI, the European Telecommunications Standards Institute.
Okay, I know them. Big standards body, especially in telecoms.
That's right. Well respected. And the fact that they've published such a detailed standard on AI security really shows how critical this topic has become, way beyond just telecoms.
And the April 2025 date confirms this is current thinking.
Absolutely. It reflects today's challenges and what we currently see as best practice.
And the why. The document's introduction makes that pretty clear, doesn't it?
It does. It emphasizes how pervasive AI is becoming, and therefore how critical it is to protect these systems. They're integrated into so much, making them really high-value targets.
Yeah, makes sense.
And right away, the intro makes this distinction. AI security isn't just a flavor of general cybersecurity. It's got its own unique dimensions.
Like what, specifically?
Well, it points out things like data management operational differences, how you handle data for AI training data, input data, model data. It's just operationally different and brings different risks compared to, say, managing a traditional database.
Right. Because the data is the system, in a way. It's constantly shaping it.
Exactly, which makes it a unique attack surface. And that leads to things like data poisoning, which the document calls out.
Ah, yes, that's the one where attackers sneak bad data into the training set. Right.
Precisely. The goal isn't necessarily to break the AI, but to subtly skew its behavior. Make it biased, inaccurate, maybe even vulnerable to later attacks.
It's like teaching a kid the wrong facts from day one. Everything they learn after that is potentially flawed.
That's a great analogy. And then there's indirect prompt injection. This is a big one for generative AI.
How does that work again? It's not the user's prompt?
No. An attacker hides malicious instructions within data the AI processes to generate its response. Think like hidden text on a web page it's summarizing, or in a document it analyzes.
Wow. So the AI picks up and executes this hidden command without the user even knowing.
Exactly. Leading to outputs or actions the user never intended. It's sneaky.
That is sneaky and a bit scary, honestly. The attack comes through the data feed. The document also mentions model obfuscation.
Yeah, that's where attackers might try to hide malicious changes they've made to a model or just generally make it harder to understand how it works, maybe to extract sensitive info later.
So definitely not your standard cyber threats.
Nope. New tech, new vectors. And the standard provides that life cycle structure we talked about. Design, development, deployment, maintenance, end of life.
Which really hammers home the point that security isn't just a setup task.
Right. It needs constant attention right through the system's entire existence.
Okay, let's talk scope. What exactly does this standard cover? And maybe just as importantly, what does it not cover?
Good question. It clearly states it provides baseline security requirements for AI models and systems. And it explicitly includes deep neural networks and generative AI.
So LLMs, complex models, they're definitely in.
Yes. And it defines AI systems quite functionally. Engineered systems generating outputs like content, forecasts, recommendations, or decisions based on objectives set by humans. It's broad.
What's out of scope?
Purely academic research AI systems. If it's just for research and never intended for deployment, this standard doesn't apply.
So it's really focused on practitioners, on real-world systems with real-world consequences?
Exactly. It's for systems where security actually impacts users, businesses, society.
And does it connect to other standards people might already be using?
It does. It mentions that its principles map onto life cycle stages in ISO IEC 22989. So it's designed to fit within existing management frameworks, which is helpful.
And it builds on existing knowledge too, right? The references section looked pretty extensive.
Oh, massively. It pulls from ISO, NIST, CISA, OWASP, guidance from big tech firms, government agencies like the UK's NCSC. It's clear they didn't start from scratch.
They're synthesizing a lot of existing cybersecurity wisdom and applying it specifically to AI.
That's the core idea. Okay, before we jump into the actual principles, we should probably nail down some key definitions the standard uses. Understanding the language is, well, pretty fundamental here.
Good call. Let's start with adversarial attack. What's the ETSI definition?
They define it as intentionally crafted inputs designed to cause an AI model to make errors or produce unintended outcomes.
And how is that different from, say, trying to hack a traditional website?
With traditional hacking, you might look for a coding bug, like a SQL injection flaw or a buffer overflow. With adversarial attacks on AI, you're often exploiting the model's learned logic, its mathematical structure.
So you're tricking the AI itself, not just the code around it.
Precisely. You find inputs that look normal, maybe even identical to humans, but they're specifically engineered to fool the AI's decision-making process.
Got it. And we touched on data poisoning, corrupting the training data to mess with that learned logic from the start.
Exactly. Then there's model inversion. This was fascinating. It's a privacy attack.
How so?
An attacker analyzes the model's outputs, what it generates or predicts, to try and infer sensitive details about the training data it learned from.
Whoa. So by querying the model enough, they might figure out private information it was trained on.
Potentially, yes. Properties of the dataset, maybe even specifics about individuals if it was trained on personal data. Big privacy implications.
That really highlights the link between security and privacy in AI. What about guardrails? The doc defines them as constraints or rules.
Yeah, constraints are rules to control the AI's output and behaviors, basically for safety and alignment. Think of them as defensive filters.
How do they work as a security measure then?
If the AI, maybe due to a weird input or an internal glitch, tries to generate something harmful, illegal, or just way off topic, the guardrails are meant to catch it. They detect and block or modify the output to keep it within safe, acceptable boundaries.
Okay, so like a safety net for the output.
A crucial one, especially against misuse or unexpected behavior from adversarial inputs.
We also need to understand prompt versus system prompt. A regular prompt is just what the user types in, right?
Right. But the system prompt is often a hidden, predefined instruction that sets the AI's core behavior, its persona, its rules of engagement.
And securing both is critical.
Absolutely. Standard prompts can be used for direct attacks, but indirect prompt injection often targets that hidden system prompt, or instructions buried in data the AI processes. So you need to protect the integrity of those system prompts and really carefully check the data the AI ingests.
Right, preventing attackers from hijacking the AI's core instructions. That makes sense. Then sanitization, cleaning data.
Yeah, cleaning and validating data or inputs, removing errors, inconsistencies, but crucially also malicious content.
And why is this especially vital for AI?
Because AI is just so data hungry and data sensitive. Good sanitization is your first defense against data poisoning during training and against malicious inputs during operation. You need to trust the data the AI is learning from and responding to.
Okay. And finally, threat modeling and risk assessment. Familiar terms, but how are they applied here?
The standard emphasizes they must be tailored for AI. It's not enough to think about network threats or standard software bugs.
You have to specifically consider the AI risks.
Yes. Data poisoning, adversarial attacks, model inversion, membership inference. These specific AI threats need to be part of your threat modeling and risk assessment process.
Okay, that vocabulary helps a lot. Now, who needs to pay attention to this? The standard defines different roles, different stakeholders.
It does, and assigning responsibility is key.
Yeah.
First up, developers. These are the folks actually creating or adapting the AI model or system. Could be a big company, could be an open source team, anyone building the AI.
Okay, the builders, then.
System operators. They're the ones who take that model and embed it, deploy it, maintain it in their own environment. Often the organization using the AI or offering it as a service.
So the ones running it in the real world.
Exactly. Then data custodians, super important role. They control the permissions for and the integrity of the data the AI uses.
Right. Managing the fuel. They might be part of the same company or external.
Could be either. Their focus is ensuring the data is secure and used appropriately.
And obviously, end users, the people interacting directly with the AI.
Yep. Employees using an internal tool, consumers using a chatbot, anyone hands-on. They need awareness, even if they aren't security experts.
And there's one more group.
Affected entities. This is broader. It includes people or even other technologies impacted by the AI's outputs or decisions, even if they don't directly use it.
Like someone affected by an AI-driven decision in, say, loan applications or resource allocation.
Exactly. Or someone impacted by an autonomous vehicle's actions. Their safety and security are also considered?
And the doc notes that one organization can play multiple roles, right?
Yeah, definitely. If you build and use your own AI tool, you're both developer and system operator. Data custodianship might also be shared.
And it stresses that senior leadership has ultimate responsibility.
Yes, and that all stakeholders have data protection obligations. Understanding these roles matters because the principles we're about to discuss often assign primary responsibility to specific groups. It clarifies who does what.
Okay, great. So we've got the background, the terms, the players. Let's get into the heart of it. The 13 principles, starting with the first phase. 5.1 Secure Design, Principles 1 through 4. This is all about building security in from the get-go.
Absolutely, and Principle 1 is foundational. Raise awareness of AI security threats and risks. This is mainly aimed at system operators, developers, and data custodians.
And it gets specific quickly. Provision 5.1.11 says cybersecurity training must include AI security content.
And this is key. It must be regularly reviewed and updated.
Why is that regular update piece so critical, especially for AI?
Because the AI threat landscape is moving incredibly fast. New vulnerabilities, new attack methods like sophisticated prompt injections or ways to poison data, they're popping up constantly.
So training from even 6 months ago could be outdated.
Easily. Continuous learning isn't just nice to have. It's essential to keep defenses relevant.
The standard also says training needs to be tailored by role. That makes sense.
Totally. A developer needs the deep technical dive on algorithmic weaknesses. A data custodian needs to focus on data integrity risks. An end user needs practical guidance on safe use and spotting red flags. Generic training just won't be effective.
Beyond formal training, it also mentions keeping all staff aware of the latest threats and mitigations. How would that work?
Think ongoing communication security bulletins, internal newsletters, maybe dedicated channels sharing info on new threats as they emerge, keeping security top of mind.
Okay, moving to Principle 2. Design the AI system for security as well as functionality and performance. Classic security principle, but applied to AI. Who's this mainly for?
Primarily system operators and developers. And it starts right at the concept phase.
How so?
Before you even start building, the standard says you shall do a thorough assessment. Define the business need, yes, but also explicitly identify the AI security risks and think about mitigations from day one.
So security isn't an add-on, it's a core design requirement.
Exactly. And if your data custodians are internal, they must be involved in these early design talks.
Because they know the data, its sensitivity, the rules around it.
Precisely. Their input is vital for designing systems that handle data securely right from the start.
What are some key technical design aspects mentioned here?
A big one is designing systems to withstand adversarial attacks, unexpected inputs, and failures. Building in robustness, making the AI resilient to manipulation and edge cases.
That sounds challenging.
It is. Another key requirement is documenting everything and creating a solid audit trail. Data prep, model lifecycle, datasets, prompts, configurations.
Why is that audit trail so critical for security?
If something goes wrong, a breach, unexpected behavior, you need that trail to trace back what happened. How was it built? What data was used? What changed? It's essential for forensics and incident response.
It also mentions due diligence for external components, like third-party libraries or models.
Yes, you need to assess the security of anything you pull in.
Yeah.
And data custodians have a role here too, ensuring the planned use of the AI aligns with the sensitivity of the data involved.
Hmm.
You wouldn't train a public chatbot on super sensitive internal data, for instance.
Principle 3, then. Evaluate the threats and manage the risks to the AI system, again, for developers and system operators.
Right, this is about ongoing AI-specific threat analysis and risk management. Regular threat modeling is recommended, and it should explicitly include those AI threats we defined: data poisoning, model inversion.
And that other one, membership inference.
Yes, membership inference. That's trying to figure out if a specific person's data was in the training set. Huge privacy risk, especially for models trained on user data.
And this isn't just a one-off assessment at the start.
No, the standard is clear. Risk management shall address risks from new settings or configurations anytime during the lifecycle. Deploy it differently, fine-tune it. You need to reassess the risks.
That makes sense. New context, new potential vulnerabilities.
And there's an interesting point about superfluous functionalities.
What does that mean?
Imagine you have a powerful multimodal AI that can handle text, images, and audio, but you only deploy it to use the text part.
Okay.
The standard says you shall manage the risks associated with those unused image and audio capabilities. They could still be potential attack surfaces or cause unexpected issues, even if you're not actively using them.
Huh. That's a subtle but important point. Functionality you don't use can still be a liability.
Exactly. The standard is also practical, though. It says system operators shall apply controls based on cost and corporate risk tolerance. It's about finding the right balance, managing risk effectively within real-world constraints.
One provision here seems really crucial: the communication chain for unresolved threats.
Yes, this is vital. If developers find threats they can't fix, they shall tell the system operators. The system operators shall then inform the end users.
And this communication should be detailed.
It should, yes, explaining the risks, the potential impacts, and any recommended actions or workarounds. End users need this transparency to use the system safely and understand its known limitations.
That builds trust too. What about external providers like cloud platforms?
System operators need to get assurance from them that the underlying infrastructure meets security requirements. Shared responsibility means verifying your partners.
And Principle 3 finishes by acknowledging residual risk.
Right. Continuous monitoring based on risk appetite is recommended, with the explicit understanding that you can't eliminate all risk. It's about ongoing management.
Okay, Principle 4. Enable human responsibility for AI systems. Again, developers and system operators. This feels really important given how complex AI can be.
It is. It starts with designing in capabilities for human oversight right from the start.
Why is that necessary? Can't the AI just run itself?
Well, AI can fail in complex, unpredictable ways. Having a human in the loop, or at least the capability for human intervention, is a critical safety net. Humans can catch errors, override bad decisions, handle situations the AI wasn't trained for.
But for humans to oversee effectively, they need to understand what the AI is doing.
Exactly, which is why the standard says developers should design systems to make human assessment of outputs easy. This links directly to explainability and interpretability.
Making the black box less black.
That's the goal. It's challenging for complex models, but crucial if humans are expected to be responsible for the AI's actions.
And if human oversight is intended as a specific risk control measure,
Then technical measures must be designed and maintained to actively support and enable that oversight, making it more effective at reducing risk. Technology should help the human reviewer.
this principle also loops back to the data custodian, requiring developers to check that the security controls they specified are actually built in.
Yes, connecting data requirements to implementation. And it circles back to user education too, making end users aware of prohibited use cases. Setting clear boundaries is a security measure in itself.
Okay, so secure design is about awareness, embedding security thinking early, continuous risk assessment, and ensuring humans can stay in control. A strong foundation.
Entirely. Shall we move to the next phase?
Let's do it. 5.2, secure development. This covers principles 5 through 9. This is where we actually build the thing securely based on that design.
Right. Principle 5 is identify, track, and protect the assets. This involves developers, system operators, and data custodians.
Asset inventory sounds standard, but the document notes increased complexities for AI assets. Why is it harder?
Because AI assets aren't just servers and code. You've got multiple versions of training data, test data, the models themselves, including weights, prompts, configurations, the specific code used for training, the infrastructure.
Wow, yeah. Tracking all that and the relationships between them, which model used which data, trained with which code, sounds much harder.
It is. So the standard requires processes and tools specifically capable of handling this complexity for tracking, authentication, version control, and securing these diverse AI assets.
And disaster recovery needs tailoring, too, for things like model corruption.
Exactly. You need to be able to restore to a known good state, not just for your servers, but for your verified, uncompromised models and datasets.
Protecting the training data gets special mention again here.
Yes, protecting sensitive training and test data from unauthorized access is paramount. It often contains proprietary info or personal data.
And data sanitization comes up again during development.
Yes, applying checks and sanitization during model design, and crucially, whenever models are revised or undergo continuous learning, you have to keep cleaning the input stream.
Because new data could introduce new problems.
Precisely. And if the training data or model weights are confidential intellectual property, they need proportionate protection, like strong access controls.
Okay, principle 6. Secure the infrastructure, mainly for developers and system operators.
This covers the whole environment, evaluating access controls for APIs, the models themselves, data stores, the training pipelines. Everywhere, data flows or compute happens.
It specifically calls out securing external APIs for AI models. Using rate limits as an example, how does that help security?
Attackers might hammer an API with queries to try and reverse engineer the model, find adversarial examples, or perform model inversion. Rate limiting makes these brute force attempts much harder and more expensive for the attacker, slows them down.
Ah, I see. It's a simple but effective defense. What about dedicated environments?
The standard requires dedicated, separated environments for development and tuning with strong technical controls. This is especially important for AI because you're often handling very sensitive training data during these phases. Isolation reduces risk.
Principle 7 is secure the supply chain, involving developers, system operators, and data custodians. The AI supply chain seems more complex than just software libraries.
It really is. You've got pre-trained models from third parties, data sets from all sorts of places, specialized hardware, frameworks. The standard says you need secure software supply chain processes, but adapted for all these AI-specific components.
What if you have to use a component that isn't maybe perfectly documented or secured, like an open source model with unclear origins?
The standard acknowledges this can happen. If it's necessary, you shall justify using it, document the risks, and importantly,
Implement mitigating control.
exactly, provision 5.2.32.1, you don't just accept the risk, you actively try to reduce it. And 5.2.3-2.2, you should share that justification with end users. Transparency again.
And a really key point here, you have to reevaluate third-party models yourself.
Yes, developers and system operators shall rerun evaluations on released models they plan to use. Don't just trust the vendor's spec sheet or a published paper.
You need to test its performance and security in your specific setup with your data.
Non-negotiable, context matters hugely in AI. The standard also requires communicating model updates to users beforehand because updates can change behavior.
Okay. Principle 8. Document data, models, and prompts. Primarily for developers. Documentation might not be glamorous, but it's vital.
Foundational, really. Developers shall document the system design, maintenance plans, and should share this downstream with operators and custodians. That trail is essential for understanding and security.
And the standard specifies security-relevant details to include.
Yes, provision 5.2.41.1. Things like training data sources, the model scope and limitations, any guardrails implemented, data retention plans, review frequency, known failure modes, all the crucial context.
It also mentions cryptographic hashes for model components. Why is that important?
It's about integrity. Provision 5.2.41.2. A hash is a unique digital fingerprint. If a developer releases a model component with a hash, anyone using it can verify that the component hasn't been tampered with by recalculating the hash. Essential for supply chain security.
That's clever. And documenting sources for public training data.
Yes, provision 5.2.42. Record the URL, the date time you downloaded it. Why? Because public datasets can get poisoned after you've used them. If a known poisoning attack happens later, you can quickly check if your model might have been affected by tracing your sources.
Smart forensic readiness. And tracking changes to system prompts.
Also important, provision 5.2.43. Keep audit logs of changes to system prompts or critical configurations and make them available. Those prompts control core behavior. Unauthorized changes need to be detectable.
Finally, for development, Principle 9. Conduct appropriate testing and evaluation for developers and system operators. You built it, now you test it.
And test it thoroughly. Developers must test models, apps, systems for security before release. Then, system operators shall conduct their own testing before deployment, often with the developer's help.
Shared responsibility for testing. It also recommends independent testers.
Recommends, yes, provision 5.2.52.1. Independent testers bring fresh eyes, specialized skills, and aren't biased by having built the system. They often find things internal teams miss.
And sharing findings between dev and ops.
Encouraged, provision 5.2.53 helps the operator tailor their pre-deployment testing to cover known weak spots or areas of concern found during development testing.
The testing also needs to cover AI-specific output issues.
Yes, provision 5.2.54 and 5.2.54.1, evaluating outputs to check if they can be used to reverse engineer a sensitive model or data details, or if they can be manipulated to influence the wider system. Testing the consequences of the AI's output.
Okay, so secure development is about meticulous management of AI assets, securing the unique infrastructure, verifying the supply chain, comprehensive documentation with integrity checks, and rigorous AI-aware testing.
That captures it well. It's about translating secure design into secure reality.
Right. So we've designed it securely, built it securely. Now, 5.3 secure deployment, which is mainly Principle 10, getting it out into the world safely.
Exactly. And Principle 10 is all about communication and processes associated with end users and affected entities, primarily the system operator's job, with developer support.
This seems very focused on transparency with the user.
It is. System operators must tell end users, and in clear language, how their data is used, accessed, stored. Provision 5.3.111. Is it used for retraining? Does a human review it? Users need to know.
And if it's an external developer's AI,
The developer shall provide that information to the system operator so they can inform the end user. The responsibility flows.
operators also need to provide guidance on using the system.
Yes, provision 5.3.12, accessible guidance on how to use, manage, configure the AI safely and effectively.
And that guidance needs to cover limitations and potential failures.
Absolutely, provision 5.3.12.1. Managing expectations is key. Telling users what the AI can't do or what situations it might struggle with helps prevent misuse and builds realistic trust. It's a security control in itself.
Users also need to know about security updates.
Proactively, yes. Provision 5.3.12.2, informing users about updates that affect security, with clear explanations.
And the principle extends to incident response, supporting users after something goes wrong.
Yes. Provision 5.3.13. Supporting end users and even those affected entities during and after an incident, helping with containment, mitigation. Responsibility extends beyond just fixing the system. Documenting these support processes is vital.
So deployment is heavily about managing that human interface, transparency, guidance, support.
That's a big part of it, putting the system into operation responsibly.
Okay. But once it's deployed, it's not set and forget. Let's look at 5.4 secure maintenance, principles 11 and 12, keeping it secure over time.
Right. Principle 11 is straightforward but critical. Maintain regular security updates, patches, and mitigations for developers and system operators.
This outlines the update process.
Yes, developers shall provide updates, patches, and notify operators. Operators shall then deliver them to end users. Provision 5.4.11, a defined update chain.
What if an update can't be provided right away, say, for a complex vulnerability?
The standard requires having mechanisms or contingency plans for that. Provision 5.4.11.1, maybe temporary workarounds, stricter monitoring, documented mitigation steps while a full patch is developed.
And major AI updates need retesting, like new versions.
Yes, provision 5.4.12. Significant changes to AI models can introduce entirely new security issues, so they need the same rigorous testing as a new release. Developers should also support operators in integrating these updates securely.
Okay, patching and updating. What about Principle 12? Monitor the system's behavior, also for developers and operators.
Monitoring is essential for catching problems post-deployment. It starts with basic logging. System operators shall log system and user actions for compliance, investigations, remediation. Provision 5.4.2 doing, that's your evidence base.
But AI monitoring goes beyond standard logs.
Has to. Provision 5.4.22. You shall analyze logs specifically to check if models are producing desired outputs and critically to detect anomalies, breaches, or unexpected behavior over time.
Like looking for signs of data drift.
Exactly. Or detecting delayed onset data poisoning that only shows up later. monitoring for subtle shifts in behavior that could indicate a compromise or degradation.
The standard also mentions monitoring internal states.
Where possible, yes. Provision 5.4.23. Looking inside the model's workings can provide deeper insights for diagnosing threats or understanding unexpected outputs.
And tracking performance.
Key. Provision 5.4.24. Monitoring model system performance over time. A sudden drop in accuracy, a weird shift in the kinds of outputs it generates these, could be symptoms of a security problem, like an ongoing adversarial attack or drift, making the model unreliable.
So maintenance is about proactive patching and continuous AI-aware monitoring for any signs of trouble.
Precisely, keeping the system healthy and secure throughout its operational life.
That covers almost the entire life cycle. Just one phase left. 5.5, secure end of life. Principle 13, what happens when you retire an AI?
Right, security doesn't stop just because the system is turned off.
Right.
Principle 13 is ensure proper data and model disposal, involving developers, operators, and data custodians.
This covers transferring assets too.
Yes. Provision 5.5.1-1. If you transfer or share ownership of training data or models, data custodians shall be involved to ensure it's done securely and any assets not being transferred are properly disposed of. Don't want sensitive stuff leaking during a handover.
And for full decommissioning.
Again, involve the data custodians. Provision 5.5.12. Securely delete all applicable data training data, model weights, configuration details, anything sensitive that could be misused later. Proper digital shredding.
It's easy to forget this step, but leaving old AI assets lying around sounds like a recipe for trouble.
It really is. Improper disposal is a potential vector for data breaches or IP theft long after the system is gone. Completing the secure lifecycle means securing the end, too.
Okay, wow. We've covered a lot of ground there. We've walked through the entire AI system lifecycle according to this ETSI standard.
From secure design through development, deployment, maintenance, and right to that secure end of life.
Covering those 13 core principles that ETSI lays out as a baseline for securing AI systems.
Highlighting the unique challenges AI brings: data poisoning, adversarial attacks, model inversion, supply chain complexity, and the specific measures needed at each stage.
It really feels like a significant piece of work from ETSI, giving organizations a structured way to think about this complex, fast-moving area.
It is. It's a solid blend of proven security practices and new AI-specific requirements. A much-needed foundation.
But as you said, and the document implies, it's a baseline. This isn't the final word.
Absolutely not. The AI security landscape is incredibly dynamic. The standard reflects current understanding, but practices will have to keep evolving as AI technology and attack methods change. Continuous learning applies to security practitioners, too.
A very good point. Well, that brings us toward the end of this deep dive into securing AI, guided by ETSI TS 104223. Thank you for joining us as we explored this vital standard.
It's been great digging into it. It's such a critical topic for building trust in the AI systems that are becoming, well, part of everything.
So, to leave you, our listener, with something to chew on after this discussion. As AI becomes even more deeply embedded in critical systems, how will the clear assignment of security responsibilities across this complex supply chain think about it? From the developer building the model, to the data custodian managing its fuel, the operator running it, and the end user clicking the button. How will that need for clear responsibility fundamentally change how we approach digital trust and accountability in this age of AI?
And maybe think about which of these principles we discussed feels like the biggest hurdle to implement effectively in the real world, or which one feels most critical for getting AI security right going forward. There's definitely a lot to consider.
Absolutely. Thanks again for going on this deep dive with us. We'll catch you next time.